Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problems 6 to 10 of our volume 2 of the 2020 AP Calculus AB multiple choice practice exam questions. Do not forget, we have 5 practice problems at the end of this presentation that we'd like you to try out in order to demonstrate that you've mastered what we covered in this tutorial. If you'd like to gain access to our entire playlist and other valuable learning resources, take a look at the links in the description or just visit our website at mathgotserved.com. Alrighty, let's take a look at question 6. In question 6, we're going to look at how to apply the implicit differentiation procedure in finding the SOT. So you might wonder, what is SOT? Well, SOT means the slope of the tangent line. Alrighty, anytime that you're looking for the derivative at a point, you have to, what you're looking for is the slope of the tangent line. They basically are one and the same. Alright, so when you're differentiating implicitly, there's something that most students forget. Okay, so let's address that real quick. When differentiating implicitly, most students forget to check for agreement and they forget to apply the chain rule where applicable. Okay, so recall to check for agreement when you are differentiating implicitly. Alrighty, so in this problem, we're differentiating with respect to x. So any term that's in terms of x as a function of x, we have agreement. Okay. But if it is any other variable, when we differentiate that term, we have to add d of that variable, dx, to indicate that we do not have agreement. Okay? All right, let's go ahead and apply it here. In this scenario, we have x plus, we have 2y to the 1/2. I'm going to write it as 2 root y so I can differentiate quickly, equals y. All right, so when we differentiate the first term x, we have agreement here. The derivative of x is just 1. Okay, you can add on dx, but it cancels out, so you don't have to bother. Now, when you're differentiating this term right here, you're going to have, now this is, you can use the power rule, but I like to use this shortcut right here. The derivative of root x is equal to 1 over 2 root x. So if you have this mastered, it's going to really save you a lot of time. All right, so the derivative of 2 root y is going to be, so factor out the 2 and differentiate root y. You're going to have 2 over 2 root y. Okay? And then, is that it for this term? For the derivative of this term with respect to y? The answer is no. So the mistake most students make is they go on and just say, oh, the derivative of this right here is dy dx, which is incorrect. Since we have disagreement, this variable differs from that. We have to apply the chain rule and add on dy dx because x and y do not agree. The same applies to the right side. The derivative of y is just 1. And then applying the chain rule, because we have disagreement, we'll add on dy dx. Okay. All right, let's make it look pretty. We're going to have 1 plus 1 over root y dy dx equals dy dx. Now what we're going to do is we're going to collect all the terms that have dy dx to one side of the equation and then isolate dy dx. It's like an algebraic process. That's what we're going to be doing right now. All right, so this term 1 root y dy dx, we're going to move it to the right side. All right, so picture subtracting 1 over root y dy dx from both sides of the equation like you normally do in Algebra 1 and 2. If you do that, you're going to end up with 1 equals dy dx minus 1 over root y dy dx. Now we're going to go ahead and factor out dy dx from the right side of the equation so we can isolate it. If we carry out the factorization, we'll have 1 equals, when we factor out dy dx from dy dx, you have 1 minus 1 over root y times the quantity dy dx. Okay. Now we're going to be dividing by this difference of these two terms right here. So let's do this. How about we simplify it first and then we can see what happens. I want to combine these two together. So I'm going to do that on the side right here. If I want to combine 1 minus 1 over root y, what I'll do is I'll multiply both sides by root y. So let's do that. I need to have the same common denominator, so I need to multiply this by root y top and bottom. So that gives me root y minus 1 over root y. That's basically what this difference is. You see why I'm doing that in a second. So if I combine these together, these two, I will have root y minus 1 over root y. Okay, so that dy dx is equal to 1. Okay, so to get dy dx by itself, I need to get rid of this coefficient. So what do I do to both sides? Rather than divide by this coefficient, I can multiply by its reciprocal. So since I have it already combined nicely, I can just multiply by root y over root y minus 1. Okay. All right, so when we do that to the left, we do exactly the same thing to the right to preserve equality. And then we have root y minus 1. And then on the right side, these divide out. Goodbye. Left with 1. And these divide out. Left with 1 also. So we have the slope. Okay, so dy dx, the slope at any point is root y over root y minus 1. Alrighty, so in order to finish this off, we just have to evaluate the derivative at this particular point, 15, 25. So let's do it. So dy dx, we're going to find the SOT, which is dy dx at a point. The point that we are looking at right here is 15, 25. So notice it's dependent on the y, right? So it's going to become root 25 divided by root 25 minus 1, which is going to give us root 25 is 5 over root 25 is 5 minus 1, 4. Answer to question number 6 is 5 over 4. Option letter C. All right, in question number 7, we're going to be working on our differentiation techniques. Have you mastered your differentiation techniques? Well, this question is going to test you right now. Okay, so in question 7, we're looking for the derivative with respect to x of x to the 10 plus 8 to the x. Okay, so let's go ahead and differentiate that. We're going to carry out term by term differentiation. So derivative with respect to x of x to the 10 plus the derivative with respect to x of 8 to the x. So what is the derivative of x to the 10? The derivative of x to the 10, power down, using the power rule, 10x to the 10 minus 1, which is 9 plus. Now let's go over this formula right here. It's very easy to forget this formula or mess it up. That's why it always shows up on the AP exam. Okay, so the derivative of a to the x is a to the x ln a. An easy way to remember this is, do you know what the derivative of e to the x is? This is the easiest one. Everybody knows it. The derivative of e to the x is just e to the x. But guess what? There is also another component here, namely ln e, the natural log of the base of your exponent. But what is the natural log of e? The natural log of e is 1. So that is why the natural log, that's why the derivative of e to the x is just e to the x, because the ln and the e cancel each other out. So it's there, it's hidden, but you don't see it. So it's just e to the x. So one mistake most students make is, they say, you know what? The derivative of a to the x must be a to the x, because the derivative of e to the x is e to the x. So this is wrong. Please do not do this. You have to add on that ln a component. All right, so what's the derivative of 8 to the x? The derivative of 8 to the x is 8 to the x power times the natural log of the base of the exponent, which is 8. Okay, so the answer to question, supposed to be plus, the answer to question number 7 is option letter D. All right, question number 8, we're going to be working on limits at infinity. Okay, so in this particular problem, we're looking for the limit as x approaches infinity of x minus 8x to the 15 divided by 2 plus 2 ln x. So we could have used table for this particular limit, but we have a scenario. We have something going on here. We have a logarithmic component. Okay, so whenever you are working with infinite limits involving just polynomials, you can use top heavy plus or minus infinity, equal way to divide, bottom heavy 0. But when you have exponential logarithmic functions, they exhibit interesting behavior. So you want to use relative rates for this. Okay. So relative rates as x tends to infinity, we have the following growth rates. The slowest to the fastest, ln x is the slowest, followed by the polynomial function x to the n, and your exponential function is the fastest growing function. Okay, so this is from the slowest to the fastest. All right, so if you have a fast function divided by a slow function, it's going to be top heavy. If you have a slow function divided by a fast function, it's going to be bottom heavy. Okay, all right, so in this limits scenario, like right here, we're going to look at the numerator and the denominator first and ask ourselves, which are the terms that dominate in the numerator and the denominator? Those are the only ones we will consider. Okay, so check this out. This limit becomes limit as negative 8x to the 15. Limit as x approaches infinity of negative 8x to the 15 over 2 ln x. Now, wait a minute. What just happened? Well, what happened is that we took the fastest growing term in the numerator, which is this term right here. How do we know it's the fastest growing one? Well, the power is 15 and this term is 1. Which one do you think will grow faster at infinity? X to the 15 or x to the 1? Of course, it's going to be x to the 15, right? In the denominator, this is a constant, and this is it's a variable function. Although it's slow, it's not a constant. So even slow functions are faster than constants, okay, at infinity. So in the denominator, we took this guy right here, because even though it's slow, compared to 2, it's faster. Okay, all right, so now we have the fastest in the numerator and the fastest in the denominator. Since we have a logarithmic function, let's look here, look at our growth rates, our relative rates. Polynomial family and logarithmic family, which one is faster? It's the polynomial, right? So this is a top-heavy scenario, okay? So in a situation like this, when you have top-heavy, the limit is going to be plus or minus infinity. Okay, so we just have to look at the sign to determine what's the accurate sign is. So this is, let's put a note right here. This is top heavy. And then when it's top heavy, it's plus or minus infinity, right? Okay, but we have a minus here that automatically tells us that we're going to have negative infinity as the answer to question number 8. All right, so our answer is, what is our answer? Option C. So just think about, I want to talk about growth rates. In this particular scenario, the reason why we said it's top heavy is just because we have a negative fast function over a slow function. And towards infinity, the fast function could look like, it keeps going as a fast function, and the bottom basically becomes like a constant. It's like it's not really moving, and the top keeps growing. So in a situation like this, you have negative infinity. That is why our answer is negative infinity. Okay, for question number 9, we've been tested on how to find the area between two curves. Okay? Question 9 reads, let R be the region bounded by the graphs of y equals x and y equals 2x minus 1/2 x squared. Question, what is the area of R? So let's go ahead and write down the formula that's going to guide our problem solving process. So the formula for finding the area between two curves. So this is in a function of x, so it's going in the x direction, right? In the direction of the x-axis. So basically we have, if you're going in the direction of the x-axis, you're going to have two functions configured something like this, okay? So in a situation like that, you're going to have a function on the top and a function on the bottom. So the area is going to be the integral from the left or smaller x value to the bigger or the right x value of the function that's on the top minus the function on the bottom. And since we're configured vertically, it's going to be with respect to x. There you have it. Okay. All right. So the first question we want to ask ourselves is, what's the top function and what's the bottom function? The problem tells us that the region is bounded. So you have a quadratic function and a linear function. In order for them to bound the region, what must be the case? It must be the case that, let's make a sketch so you see exactly what's happening. It's implied that one function has to be on the top. You can do the calculations if you want. Okay, so we have a quadratic function and a linear function. In order for them to bound a region, we need to have a function like this, the quadratic, and then we have a linear function. The linear function has to be underneath so that it can bound the region, or else it's not going to work. Okay, so it's implied here that the quadratic function is f top, is on top, and the linear function is on the bottom, f bottom. Okay, all right, so let's go ahead and write that down. So the top function, f top, is the quadratic that's upside down, and the bottom function is the linear function, which is y equals x. There's another way that you can verify this. I'll show you in a second. So in order for us to be sure that the quadratic is on top, we want to look at what is the magnitude, what is the value of each function within the interval right here that they bound the region. So in order to do that, we need to figure out our x left and our x right. These are points of intersection. So to find our points of intersection, we are going to set both of them equal to each other. Okay, so our task that we want to execute now is we want to find x left and x right using algebraic processes. So we're going to set these two functions equal to each other. So x equals 2x minus 1/2 x squared. And then we're going to flex our algebra muscles in determining what the value of x is. Okay? All right, let's do it. So we just set it equal to 0. So it's a quadratic. So we have, let's add 1/2 x squared to both sides. So we have 1/2 x squared. And then subtract 2x from both sides. You have minus x. 1/2 x squared minus x equals 0. So how do you solve this equation? How do you solve it for x? Well, we just simply factor, right? That's how you solve quadratic equations. So to factor this, you just pull out x. So we have x times 1/2 x minus 1 equals 0. Using the zero product property, we have x equals 0, or 1/2 x equal, minus 1 equals 0. Add 1 to both sides, 1/2 x equals 1. Multiply both sides by 2, and you have x equals 2. Okay, so in this situation right here, we have the upper bound is 2, and the lower bound is 0. Alrighty, so let's put it all together. I'm going to rewrite everything that we had before so that nobody gets confused as to what just happened. So we said that f top is 2x minus 1/2 x squared. And then f bottom is x. So I also mentioned that there's a way you can verify that the quadratic is on top. So our boundaries are 0 and 2, right? So let's put it down. X left is 0 and x right is 2. Pick a number between them. So let's pick 1, for example. Okay? If you put 1 into the linear function, you get 1. If you put 1 into the quadratic, you get 2 times 1, which is 2, minus 1/2 times 1 squared, which is 1/2. 2 minus 1/2 is 3 over 2. 3 over 2 is bigger than 1, so you see that the quadratic is on top. Okay? All right, so our area, we're now ready to put everything into the formula. It's going to be the integral from x left to x right of f top, oh snap, f top. So this is the biggest mistake most students make, is they switch these two functions around. So you have to make sure that you have the formula written down and you know exactly what f top is and what f bottom is also. Okay, let's go ahead and integrate that and apply FTC1 in finding out what the antiderivative is. So we have the integral from 0 to 2, combine these two together, of x minus 1/2 x squared dx. When you integrate, you have the integral of x is x squared over 2 minus the antiderivative of 1/2 x squared is x to the third over 3, but there was a 2 there, so that becomes 6, evaluated from 0 to 2. Okay? When you plug in the upper limit, you get 2 squared over 2 minus 2 to the third over 6. And then when you plug in the lower limit, you get 0. How convenient. So this becomes 4 over 2, which is just 2, minus 8 over 6. So 8 over 6. Let's simplify that. When we find the LCD, multiply this by 6 top and bottom. So that becomes 12 over 6 minus 8 over 6. And then we get 4 over 6, which reduces to 2/3. Ladies and gentlemen, the answer to question number, what number are we on? Question number 9 is option letter A. Okay, so that's how you find the area between two curves. All right, let's take a look at question 10. It reads how, what we're looking for, basically, we're being tested on how to find the derivative given a graph, okay? All right, so let's see what we have here. It reads the graph of f is shown to the right. So we have the graph of f here. If g is f of x divided by 1 minus x squared, what is the value of g prime of 2? Okay, so we want to find g prime of 2. Do you know what this is? The derivative at a point. What is that? This is your SOT, slope of the tangent line at 2. It's a 2-in-1 process. What am I talking about? Well, first of all, you have to find the derivative. You do your calculus step first, and then after that you evaluate your derivative at the specified input value, namely 2. Okay, let's do this. So part 1, we want to find g prime of x. So g of x is the quotient of two functions, f of x, which has a graph here, and 1 over x squared. How do you find the derivative of a quotient? Do you remember your quotient rule? Well, let's go over that again. You need to have that down cold to do well on the exam, okay? So the quotient rule is u over v prime is vu prime minus uv prime over v square. There you have it. So in this case, f of x is our u and 1 minus x squared is our v. So let's apply the chain rule. We're going to have vu prime, quantity 1 minus x squared times the derivative of f, which is f prime of x, minus uv prime, a function, times the derivative of the denominator function. Please do not forget that minus, okay? So that's going to be negative 2x. And this entire thing divided by v square. Okay, so 1 minus x square square. So let's just indicate what we just did. We did v u prime minus u v prime divided by v square. That's a quotient rule for you. Okay? All right. Now that's part 1. Part 2 requires us to find, we're going to evaluate the derivative at a specific x value, namely 2, g prime of 2. Okay, so let's see, I didn't write this correctly. Let's just make a real quick correction here. Yeah, that was an incorrect equation. What we just found is g prime, not g, so gotta be careful. All right, so that's g prime of x. Okay, so now that we have g prime of x, we're gonna advance to part 2, which is to evaluate the derivative at the specified x value, which is 2. Oh, all right, so let's do that. So g prime of 2 is going to be 1 minus 2 squared is 4 times f prime of 2. What on earth is f prime of 2? Ladies and gentlemen, we have a graph here, and we need to use this graph to find f prime of 2. How do you find the derivative given a graph? That's the question. How do you find the derivative given a graph? So we remember Navier-Stiller, right? So let's write that down. All right, so when you're looking for the derivative is the same thing as the slope of the tangent line, okay? Or the rate of change. So we have a graph, so we're going to use slope of the tangent line. And when the graph is linear, the slope within that interval where the line is straight, the slope is constant. So that line is your tangent line, okay? So we're looking for f prime at 2. So the derivative of this entire, the slope of this line is equal to the derivative at every point on this entire interval from 0 to 4. Okay, so all we just have to do to find f prime of 2 is to simply use algebra, rise over run. Okay, just pick 2 points that are lattice points and then just run with it. So we can start from 0, 0. You rise 1, run 2. Rise 1, run 2. What's your slope going to be? Your slope is going to be 1 over 2. Okay, so that's how you find your derivative graphically. You use algebra. Okay, so that's f prime of 2 is 1 over 2 minus f of 2. F of 2 is the output when your input is 2, so f of 2 is 1. So times 1. And then we have negative 2x, negative 2 times 2, right there. So what's the deal with the denominator? In the denominator, we're just going to plug in a 2 in the x there and calculate what that is. So that's going to become 1 minus 2 squared, which is 4 square. Okay, now let's PEMDAS this real quick. 1 minus 4 is negative 3. So negative 3 times 2, I'm sorry, negative 3 times 1/2 is negative 3 over 2. So we have negative 3 over 2, and then this is plus 4 divided by 1 minus 4 is negative 3. And when you square that, you get positive 9. All right, so let's go ahead and finish this up. We'll find the LCD right here. So this becomes negative 3 over 2. Put this over 1 times it by 2 top and bottom plus 8 over 2 divided by 9. Okay, that gives us positive 5 over 2 over 9 over 1. You then drop, change, flip that. You have 5 over 2 times 1 over 9. Ladies and gentlemen, our final answer is 5 over 18. The answer to question number 10 is option letter D. I mean B, said D. Option letter B is the answer to question number 10. Alrighty, the time has come for you to do some practice problems. Okay, so what we'd like you to do at this time, go ahead and pause this video presentation. We'd like you to try out these 5 practice problems. We promised that we were gonna have you do some practice at the end of this tutorial. So try them out. When you're done, click on the play button, and then we're going to reveal to you what the answers to these 5 practice problems are. Alright, so go ahead and pause this video and try out these problems. Alrighty, welcome back. Hopefully you had a chance to try out the practice problems. Let's take a look at what the answers are. The answer to question 6, the answer to question number 6 is letter A. The answer to question number 7 is option letter C. The answer to question number 8 is option letter A. The answer to question number 9 is option letter D. And the answer to question number 10 is option letter B. So how well did you do on this practice problems? Did you get an A, B, a C? What did you get? Let us know in the comment section below. If there are any questions that you have about these practice problems or what we covered in this tutorial, just specify it in the comment section and we'll be glad to respond to your comments. Thanks so much for taking the time to watch this presentation. To help support our channel, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel if you haven't already done so. If you have any questions or comments as indicated earlier, just put it in the comment section below and we'll be more than glad to support you. Tons of support resources can be found at mathgotserved.com, all free. Or just take a look on the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.